In topic 3, we're going to talk about multiplying conjugates. So when we were talking about polynomials a few chapters ago, we talked about these things called conjugate pairs, okay? Conjugate pairs are situations where you're adding two terms and then subtracting those same two terms. So you have these binomial-like expressions that look the same, except in one case you add, one case you subtract. So with polynomials, we learned that something like a plus b times a minus b, these were called conjugate pairs. And you will see similar situations come up here. So you'll see this idea of conjugate pairs again. And what you need to remember with conjugate pairs, you don't have to do FOIL, okay? So to multiply first terms, multiply last terms, and then simplify. There was a shortcut, okay? So with the first example we look at, I'll do the full FOIL method and prove to you that something very nice cancels, and then in the second example, we'll just kind of cut to it. So definition, radical expressions that involve the sum and difference of the same two terms are called conjugates, okay? So we just talked about that. You can perform the FOIL method for multiplying two binomials. So just like we did in the previous video, you can use that same idea of the FOIL method when you're multiplying conjugate pairs. However, there is a shortcut that applies to conjugates. You just multiply the first terms and multiply the last terms, okay? Now, for example 3, it says multiply. So for part A, I'm going to go ahead and just do the full FOIL method, okay? So I would take this 3 in the first expression and distribute it through the second one. So 3 times 3 is 9. And then 3 times negative square root 7, I just take 3 times the negative, that makes it negative, and I just kind of tack these two things together. Remember, the radical expressions are not variables, but we treat them like variables at first. So I just get negative 3 square root 7. Well, I'm done with this 3, so I come in and I take the second term in that first expression, and then I distribute that. So I'm going to take square root of 7, multiply it by 3, so that's going to give me 3 square roots of 7. And then the square root of 7 times negative square root 7 is negative square root 7 squared. Okay? Well, we need to simplify. 9 is just 9. Nothing happens there. But we do have like terms in the middle. We have 3 square root 7, and then we have negative 3 square root 7. They're like terms. So we want to add the coefficient part, that constant factor, that non-radical factor. We can add or subtract those and then just tack on the square root of 7. Well, negative 3 plus 3 is 0. So we really have 0 square roots of 7. And that's always going to happen when you multiply conjugates. Those middle terms always cancel to become 0. So now we're left with negative square root 7 squared. Well, the square root and the exponent of 2 undo each other. So we're just left with 7. So we get 9 minus 7 is 2. And there you have it. That's it. That's multiplying conjugate pairs. Now for part, this should actually be B. That's a typo. So for part B, we have 6 plus 3 square root 2 times 6 minus 3 square root 2. Again, we have conjugates. We have 6 and 6, and then we have positive 3 square root 2 and then negative 3 square root 2. So we're adding the same terms and subtracting the same terms. We can take a shortcut. We can multiply the first terms. I'll do that in blue. And then we can multiply the second terms. I'll do that in red just so you can see what's happening. Okay, so the first terms are the 6's. 6 times 6 is 36. And then the last terms are 3 square root 2, negative 3 square root 2. So positive 3 times negative 3 is negative 9. And then I get the square root of 2 squared. Okay, so let's see how that simplifies. I just have my 36, that's fine. I have my minus 9. And then you have to understand that the square root of 2 squared, when you square a square root, they just unravel each other. So you're just left with the radicand. So I really just get 9 times 2. So I have 36 minus 18, which is 18. So when you multiply those conjugate pairs, things simplify down very beautifully, okay? So you're going to be left with a really nice integer value.